Greetings and salutations, friends. We are continuing our journey into the world of exponents. Hang in there, guys. We've only got about 5 weeks of school left, believe it or not. So keep going, keep the pace we're going, and we'll be good for next year. All right. Things have inverses. And we talked about inverses in the last chapter. Squares have inverses, they're square roots. Cubes have inverses, they're cube roots. An exponential equation has an inverse also that we call something in the general form a logarithm. So we're going to be studying logarithms and logarithmic functions. It's kind of a cool thing to say, right? Logarithmic. I don't know. It's okay. What exactly is a logarithm? I'm going to give you the definition. And we know about definitions, okay? They don't tend to make a lot of sense until you really think about them. So a logarithm, this is the general definition of a logarithm. It's the power to which a base must be raised to produce a given number. Ugh. Okay, let me show you. Let's say you've got this. Here is what this question is asking you. If you have a base, which in this case is 2, all right, what power, I don't know the answer, must this base be raised to produce a given number? So this given number is 8. Okay. So really the question is asking this. 2 to what power gives me the answer of 8? Now you guys know this. We've been doing these exponents for a while. It's 2 to the third power. So since 2 to the third power is 8, that means the log base 2 of 8 equals 3. That's how these are related to each other. Okay? So you've got your number that you must obtain. You've got your base and a power. So you see how these numbers kind of float around. The base is 2. The power you raise it to is this number here. And what you're taking the log of the number, is going to be what that number is that you've raised the power to. Okay. It's weird to think about, and it's weird to even say, but it's pretty easy in action. So I'll show you this right now. I'll show you the general form. Let's say we take log of any base of any number. What does that really mean? What does log base a x equal y really mean? It means that base of a raised to the y power will equal x. This is your formula to remember for logarithms. Okay. I promise once you see this in action, it's not going to be too crazy. But something you must know, and this is the important thing about it, logarithmic functions are inverses of exponential functions. And I'll show you that, especially on the last two problems, which are graphs. But if you look at this, you kind of see how these are related to each other. All right, let's take some examples, and you'll see where it's really not really insane. I just want to rewrite this in exponential form. That means I take my base of 3. If I raise that to the 5th power, it should equal 243. So if I could animate this, I would take that base of 3 and just bump it right there. So it'd be 3 to the 5th power equals 243. Okay? So think about that. I'm going to take that 4, I'm going to put it right there, which means that 4 raised to the 3rd power equals 64. And you know those are true. 4 times 4 times 4 is 64. 3 times 3 times 3 times 3 times 3 is 243. You can check that in your calculator. It's great. All right, how do we write this? 9 is your base to the 1/2 power equals 3. 5 is your base to the -2 power equals 1 over 25. There we go. That's it. Can we turn it back the other way? All right. Your base is 2. So log base 2 if you want to reach an 8, you got to do it to the third power. 2 to the third equals 8. That's how you do it. Base is 3. If I want to get 9, I got to take that base and square it. 3 squared is 9. That's how these work. Log, the base is 8. If I want to get 1 over 64, it's 8 raised to the negative 2 power. See how this works? Not so bad, huh? Their base is 1/3. If I want to get 1/9 from 1/3, I take it to the second power. 1/3 squared is 1/9. 1 times 1 is 1. 3 times 3 is 9. That's how these work. Now I'm going to ask you to put on your thinking caps and do a little mental calculation. What will this be? Well, one common way to do it at first, to think about it, that it equals some number. So that means that 5 raised to some number should equal 25. Well, 5 what is 25? 5 to the what power? Well, 2. So what is the log base 5 of 25? Yeah, it's 2. That's what you're thinking of. 5 to what power would give you 25? You might be able to figure this one out pretty easily. 9 to what power gives you 3? And be careful, it's not 2, because 3 squared is 9, but it's not that. It's 9 to what power would give you 3? Now, if you're not sure, and it's okay if you're not sure, what the answer is, go and do what we did in the last section. Make these the same base. How do I make 9 and 3? What would they would have the base of 3. This is 3 squared. This is 3 to the first power. The bases are the same. I set the exponents equal to each other. So if I divide both sides by 2, I get y equals 1/2. This answer is 1/2. Okay. And remember, 1/2 to a 1/2 power means the square root. So, oops, that should be a 9, not a g. We'll just do that. Okay. So is this true? It is. 10 to what power would give you 1,000? Yep, to the third. Okay. 125 to what power would give you 5? What do you think? Some of you already know. I'm going to tell you it is 1/3. If you weren't sure if it was 1/3, remember you can write 125 as 5 to the third. Now how do you do that? It's just the things we've been practicing over and over and over again. So 5 to the third times y equals 5. We know this to the first power. 3y equals 1. So y equals 1/3. All right, here we go. 4 to what power gives me 1 over 64? Oh, now I'm trying to change a number into a fraction. Because it's becoming a fraction, I got to deal with negative exponents. Remember negative exponents, they flip things around. Do you guys remember that 4 cubed equals 64? Because we've been doing that a lot. 4 times 4 times 4 is 64. Well, if that's true, if I make that a negative, remember that turns that into a fraction, just a reciprocal of what it was. So this answer is -3. All right, 5 to what power would give us 1 over 625? Now you notice 1 over 625, again, is a fraction with a 1 as the numerator. Y is going to be a negative value. Do you know to what power it takes 5 to get to 625? And if you're not sure, hopefully remember how to figure that out. Take your 625, break it down. You end up with 4. 5 times 5 times 5 times 5. So if I want 1 over 625, I make that a negative. So it's a -4. See how it all works? 8 to what power would give you 512? Now, we're not doing anything crazy yet. Crazy is for later. So 8 times 8 times 8. How many 8s do you need to get there? And you can just do a little easy manipulation to see that that's 3. 8 times 8 times 8. Take your calculator. Do 8 times 8. See what you get. Multiply by 8. If you do it 3 times, you get 512. All right, 27 to what power would give you 1/3? Now I kind of got a double thing going here. We got 27. We then made it into a 3, but it's also a fraction. So let's do it this way. 27 is 3 to the 3rd power. Okay, and times y. 1/3 is 3 to the -1. So I just converted these to the base of 3. So I know 3y equals -1, which means y would equal -1/3. So they get a little tricky. You got to really think about them sometimes and kind of work them out if you're not sure. But after a while, you get pretty good at them. All right, now we're going to graph a log function. We're just doing the basic log functions. We're not going to do anything too crazy. We're not going to shift it up and down, left and right. That's really not that important. What's important is understanding how do you graph just a log function. Now, I want to take you back to something I said earlier. Logarithmic function is an inverse of an exponential function. So what I mean by that is what we've been doing the whole time is we've been taking these things and making them into exponential functions. Okay? We turned this into 8 to the y equals 512 and solved it. We turned this into 27 to the y equals 1/3 and solved it. So what could I turn this into? My base is 3. F of x, another name for f of x is y. And the number I'm trying to obtain is x. So do you see how these two are related to each other? It's really the same thing I have rewritten. Now, how do you graph the function 3 to the y? Huh? So let me make a chart. And it's okay if we start backwards with our chart. And what I mean by that is, give me a value for y. A nice easy one. Beautiful. 0. Love it. What's 3 to the 0 power? 1. Let's just do a couple of these. Let's pick a y value of 1. Well, what's 3 to the 1st? 3. Let's pick a y value of 2. What's 3 squared? 9. Now that's enough to graph it. Because what you're going to notice, well, notice what the graph looks like. Okay. Now we're graphing these points the same way we always do. 1, 0. So here is 1, 0. Okay. Now we're going to graph 3, 1. So 1, 2, 3, 1. Then we're going to graph 9, 2. 5, 6, 7, 8, 9, 1, 2. Now the graph is going to look like this. And this is going to come down and never quite get over to 0 there. Now I want you to see something very interesting. And again, here's where the inverses lie. So if I took this graph and I switched all the points, what would this graph look like? 0, 1, 1, 3, 2, 9. It would go up like this. And it would curve like that. So do you see the inverse relationship here? Do you see how that's flipped over that line? So our logarithmic graph truly, truly is this one. That's our answer. But do you see how that's an inverse of 3 to the x? Now we're going to graph this one. The base being less than 1 makes it a little trickier just in picking our points, but no big deal. We're going to convert this the same way we converted all the problems in the past on this section. We're not changing it, we're just converting it to a different form. So if my log is a 1/2, that's my base. I'm raising it to this power, which is f of x, which another name for f of x is y, and it should equal this. Now the reason it gets a little trickier is this. We're going to do the same thing we did with the last one. We're going to pick a value for y. We're going to make it 0. If I take 1/2 to the 0 power, well, I get 1. Looks good. But here's where it gets trickier. If I let y equal 1, what's 1/2 to the first power? Well, it's 1/2. Now that's not a tricky number, but that's going to be tricky to graph. We're going to be graphing half, then 1. Same idea. If I went and did 2, it'd be 1/2 squared, which is 1/4. Now, how could I make that a little bit easier? Well, I want to pick different values for y. Look at this. If I pick -1, what's 1/2 to the negative first power? And what's a negative power do? Reciprocal. So what's 1/2 to the first? It's 1/2. Flip it over and I get 2. Notice the relationship between these two. +1, I got a 1/2. And -1, I got a 2. See the reciprocal there? So if I went -2, I would just flip that over, because what's 1/2 squared? It's 1/4. The negative means I flip it around. So isn't it much easier to graph 4 -2 than 1/4 2? And with that in mind, let's throw one more out there. Let's do a -3. So what's 1/2 to the third power? 1/2 times 1/2 times 1/2 is 1/8. The -3 reciprocates it. So it's a little bit easier to graph these points, I would say. This one, this one, this one, and this one. Can you graph 1/2 and 1/4? Sure you can. We'll graph them all if you want, but you'll see why the other ones are easier. So here's 1, 0. Here's 2, -1. Here's 4, -2. Here's 8, -3. Now notice that's going below the axis. Now it doesn't actually level off. It goes down forever. It just goes down really, really slowly. As it goes down really, really slowly, guess what? When it comes over here, it's going to go up really, really fast. So here's those numbers that weren't so easy to graph. What about 1/2 1 would be right about there? What about 1/4 2 would be right about there? So those are so close together and so difficult that they're not easy to graph. But what happens is this thing is going to go up. And now I'm going to try to do this. It's going to be really hard for me, but it's going to go up. It's never, ever, ever, ever going to quite reach 0, but it's going to get closer and closer forever. All right, it's going to look just like that. All right, ladies and gentlemen, that's logarithmic functions and graphs. So take a look at them, see what you think. If you have any trouble, let me know as usual. And as always, have a great day. I'll see you later. Bye.